Hey there and welcome back. So we talked about the linked list in the previous video, and in this video we will talk about the Deque and how we can use the linked list for a Deque, because we can see that the linked list also implements the Deque interface. So the Deque and the queue allow us to model or to make a data structure that can handle the queue. And we have the queue, we also have the Deque, and the Deque is short for double-ended queue. Okay. So if we make a Deque of car, queued cars, let's just call it that, and then we can see again we can use linked list or array Deque. All right, so if we take queued cars, then we have methods again that we recognize from the other data structures because they implement the collections interface. So we have add, we have remove, of course, and we also have the size as we did, and also iterator. But related to the queue, if we want to implement a queue here, what we probably should have is a case, if we just add the cars, then we should have a case where first we have C1 and then we have C2 and C3 in the queue, and then we have C4. Yes. So if we take a look at how it works, if we add a new, so then we can just add one, it's pretty much the same as the other. Whoop. So we can do the same thing because they also, the Deque and the linked list, of course, implements the collection interface. So we can add elements to our Deque. But then we can see that if we go to the queued cars, if we select remove, and let's just remove that one here, then it will tell us that it will retrieve and remove the head of the queue. Okay, so if we call remove, we can see we get this element back. So I can make a car, head of queue, and if we write this, if we just output that, let's just comment this code out so we don't interfere in the printout. Yes, so let's just, I think we should just make a complete printout. If we do for each car C queued cars, just like we did with the previous data structures. Let's just take C, then we will first print out the queue, and then we can write here removing head of queue. Okay, so let's see how this looks like. And let's just expand the terminal here so we can see that if we look at how they have been added, we can see the first car in the queue is C1, the Volkswagen, then we have Peugeot, BMW, Tesla. And then we are removing the head of the queue. And the head of the queue is the Volkswagen, because we can see we get actually the head of the queue and we store it in our car variable, and then we output it. All right. So this is a basic functionality of the linked list, that we can add new elements and they will be added to the end of the queue, and we can get the, if we call remove, then it will get us the head of the queue, that is C1 in this case. So a basic functionality of the queue. The linked list can also do a Deque that will allow us to perform the same operations. Let's write here, if we go right queued cars, we can see we have remove first. If we write remove, we can see we have remove first, we have remove last. So it works on both the head and the end of the queue, this one here, and also add first, add last. One difference here we can see from the linked list and the array list is that if we inspect the linked list, we can see we had linked cars get 1. So in the linked list and also in the array list, we are able to get an element based on its index because it's a list. But right now we're using a Deque. So it's not a list right now. So if we write queued cars and we are looking for a get at some index, we are not able to do this because it is a queue, a double-ended queue that works in the beginning and the end of the queue. So we can't do this with a queue. Okay. I think this is more or less what I wanted to mention about the Deque. So we have used the Deque to implement a simple queue, and we can get the head of the queue. We can also add elements to the beginning of the queue, and then we can get the element that has been in there the longest time, if we should say that way. Okay, so I hope you make this work and have fun with this. Bye bye.